deck equipment and color codes have been the design. This module will present the flight deck equipment and the cockpit security door. We will start with an overview and then cover the main components. Next, we will finish with the controls and indicators, followed by a look at normal operations. The design of the Airbus cockpit makes extensive use of push buttons. These push buttons usually have built-in status and failure indications. In general, a darkened switch indicates normal operations. Color codes have been assigned to help the crew prioritize their actions. Red indicates a warning. It means that a failure has occurred and that immediate crew response is required. Amber indicates a caution. This is a failure that the crew needs to be aware of, but an immediate response is not necessary. There are also indications that are color-coded. If a push button has a green indication, this indicates that the associated system is operating normally. A green light may be permanently illuminated. A blue indication means that the system is operating normally and the system is only used temporarily. An example of this would be the cockpit voice recorder push button. When it is selected during the cockpit pre-flight, a blue on light illuminates that will extinguish once the first engine is started. A white indication means that the push button is causing the associated system to operate in other than its normal lights out mode. Some push buttons have two dots to indicate that the corresponding part of the push button is not used for system operations. There are 2 pilot seats and 2 observer seats. There are also fixed and sliding windows in the flight deck. Circuit breaker panels are located on the overhead panel and the right rear panel behind the first officer. A secure, bulletproof flight deck door has been installed to protect the crew while in flight. The design of the door allows cabin pressure to equalize on both sides of the door in the event of a rapid decompression. The first main component that we're going to look at is the pilot seats. The seats can be adjusted both electrically and mechanically. Electric adjustment is fore and aft as well as up and down. Mechanical controls allows the crew to make additional seat adjustments. The seat may be adjusted mechanically in the same planes as the electrical adjustment. Additionally, there is a backrest recline adjustment. Other adjustments include a lumbar cushion control that will move the lumbar cushion vertically and horizontally, as well as an adjustment for the inboard armrests, which only adjust in the vertical, while the outboard armrests adjust vertically and in their pitch. Seat belts and shoulder harnesses are installed on the seat. The shoulder harnesses locks incorporate both inertial and mechanical locks. There are 2 observer seats. Both of them fold up and are unusable when folded and stowed. One of these seats is movable. This allows one observer to have a seat that is centered between the 2 pilots. The other is fixed behind the captain's seat. Each seat incorporates seat belts and shoulder harnesses. There is a sliding window available for each pilot. These windows will lock in the open position if they're opened far enough. They are usable as emergency exits should the need arise. There are 2 major circuit breaker panels installed in the cockpit. One is located in the center aft position on the overhead panel. The other is located behind the first officer's seat. A letter and number grid system is used to identify each circuit breaker. Each circuit breaker is labeled so as to provide a brief description of its purpose. The flight deck door opens into the flight deck area. It has an electric latch and is bulletproof. When the door is unlocked, it will remain closed until it is manually opened by the crew. Entry can be granted by the flight crew by using the door controls on the center pedestal. An escape panel in the door can be used to evacuate the flight deck in the event of an emergency. The escape panel is only removable from inside of the flight deck. It is removed by pulling the 2 quick-release pins installed on each side of the panel. A keypad is located near the door on the cabin side of the aircraft. This keypad allows the cabin crew to request the opening of the flight deck door. A mechanical method allows the crew to mechanically open the door. As mentioned earlier, the pilot seats may be operated either mechanically or electrically. Both sets of controls are located on the inboard side of the seat. The electrical controls consist of two switches, one oriented so that the flat part of the switch is horizontal, the other has a vertical orientation. When the horizontal switch is pulled up, the seat will rise. When the vertical switch is moved forward, the seat will move forward. As soon as the switch is released, it returns to a neutral position and the seat stops moving. There are three mechanical levers. They are located aft of the electric controls. The vertical adjustment is the forward lever. The fore and aft adjustment is the middle lever, and the seat back recline adjustment is the lever at the back of the group. The lumbar cushion adjustments are on the inboard side of the seat, near the hinge point of the seat base and the backrest. Rotating the knobs adjusts the lumbar support. The control for the shoulder harness lock is on the inboard rear of the seat back. The position of the control is either locked or unlocked. The inboard armrest is adjustable only in the vertical plane. A control lever located under the front part of the armrest is used to make this adjustment. When the lever is pulled forward and released, the armrest will ratchet to the next adjustment detent as the armrest is raised or lowered. If the lever is held in the forward position, the armrest can be moved to the desired position. When the lever is released, the armrest will settle in the nearest detent. The outboard armrest supports the pilot's arm that is used for side stick control. Two controls are used to make the armrest adjustments. Both of these controls are rollers. Rolling the control on the front of the armrest raises the pitch of the armrest. Rolling the control on the outboard of the armrest changes the height adjustment. There is also an indicator installed in the top of the armrest. It has two index arrows that move as the rollers are moved. One index has numbers, the other has letters. Once the pilot has determined a comfortable setting for the armrest, it is only necessary to duplicate the setting on another airplane instead of using trial and error. There is an adjustment for the rudder pedals. It consists of a lever located between the pedals. Pulling the lever aft releases the rudder pedal lock and allows the pedals to move forward or aft as needed. When a comfortable position is reached, the lever is released and the pedals will remain in that position. There is an index with numbers below the lever that indicates the current present adjustment position. The sliding window has a control handle with a locking button on the top of the handle. Depressing the locking button unlocks the handle and allows it to be moved. Pulling the handle to the full aft position unlocks the window and the window is opened. When it is desired to close the window, the handle is used to slide the window forward. When the window is full forward, the handle will rotate forward and then lock in the closed position. Once the window is completely opened, it will not move forward unless the locking pin is moved. This is due to a locking pin that is located near the bottom of the window guide track. This pin is not visible unless the window is open. The circuit breakers have indications that inform the flight crew about their monitored status and warn against pulling the circuit breaker. If the circuit breaker is green, it means that it is monitored, and if it opens, the crew will receive an ECAM message. A black circuit breaker indicates that it is unmonitored. If the circuit breaker has a red collar, it means that it should not be pulled by the flight crew. There are only a few red circuit breakers. They control equipment like the wingtip brakes, which stop the flaps in the event of a flap asymmetry. There is a security door keypad in the cabin near the door. It allows the emergency cockpit access code to be entered, if that is necessary. It will also activate a buzzer in the cockpit if the correct access code is entered. If the emergency access code is entered, a buzzer sounds continuously on the flight deck for 45 seconds, the open light flashes, and the green light on the keypad flashes. After 45 seconds, the door unlocks for 5 seconds and the green light on the keypad illuminates steady. After 5 seconds, the locking solenoid will re-engage, the buzzer is silenced, and all lights extinguish. During the lockout period, the door is locked and all normal means of door operation from the cabin are inhibited. The red light on the keypad illuminates steady, the buzzer will sound, and all keypad entries are ignored. Once the lock mode times out, the system reverts back to the normal mode of operation. There is a flight deck security door control panel on the center pedestal. It has a 3-position switch to control the door. The unlock position can only be selected by pulling the switch up and holding it forward. This unlocks the door. The door does not open automatically. It must be manually opened by a crew member. When the door is unlocked, the green light on the external keypad illuminates steady. The aft position of the switch locks the door. It prevents the access buzzer from sounding, and it will not allow emergency access to the flight deck. It will also disable the cabin keypad. This will continue for 5 to 15 minutes, depending on the selection made by the airline. To renew the lockout, the switch must be moved from the locked position and then returned to lock. There is also a door open fault indicator on the panel. If the open light is illuminated, it means that the door is not closed and it is not completely locked. If the open light flashes, it indicates that the emergency access procedure has been initiated and the door will open after a preset time delay. The fault light indicates that there has been some sort of a system failure. A flight deck door indicator panel is located on the overhead panel. It provides information about the status of the locking mechanism and the pressure sensors. A strike light illuminates if a fault occurs on the associated latch. The respective channel light illuminates if a pressure sensor fault occurs. There is a manual unlocking capability for the security door. It consists of a D-ring which may be turned to retract the latches and allow the door to be opened. A peephole is installed in the door to enable the flight crew to observe who is requesting entry to the flight deck. Crews normally run the flight deck seat forward so that they can slide their flight bag into the briefcase storage area from the rear rather than lifting the bag over the seat and risking back injury. This seat movement may be done either electrically or mechanically. When the pilot is seated, the seat is adjusted using the electric controls for the vertical and the fore and aft positions. The mechanical control is used to adjust the backrest. Then the armrests and rudder pedals are adjusted. If the electrical adjustment motors fail on the seat, adjustment is made using the mechanical system. Seat belts are fastened and then adjusted using pull straps. Shoulder harnesses are connected into the central seatbelt shoulder harness connector. Normally, shoulder harnesses are left in the inertial position unless there is a reason to lock them. If needed, the flight deck sliding windows may be opened. Normally this is not necessary. The window must be checked to ensure that it is fully closed and locked as part of the flight deck setup. The flight deck security door must be locked before starting the engines. The door control normally remains in the normal position except in rare exceptions. Access to the flight deck is granted by use of the manual control after the crew has used the peephole to check the other side of the door. In the event of a rapid depressurization, pressure sensors will command the door latches to unlock. Circuit breaker panels are checked for popped breakers during the pre-flight flight deck inspection. Due to the vast amount of computerization on the A320, many circuit breakers control microprocessors. In flight, it is not permitted to reset most computers, so cycling circuit breakers in an attempt to regain a lost function is not allowed unless it is specified in the abnormal emergency procedure or the list of allowable computer resets contained in the flight manual. This concludes